Good to know. Anyway, I'm Rob. I'm an architect at Synopsys, and let's talk about multi-die systems. Synopsys has been tracking this for a couple of years, and at any given time, there's around 100 of these designs that are ongoing someplace. And you can see the split there. They're mainly in servers and AI, but NICs and switches are there too, and automotive as well as mobile are starting to ramp up. So this stuff is real. This is not, happening sometime in the future. It's happening now. But what I want to talk to you about is, can we bring back more? And 41% is the square root of 2, basically. That's the alpha scale factor that Bob Denard talked about in his paper. If you look at taking a design, shrinking it into 2 die, and putting them all on top of each other, the size is reduced by a factor of the square root of 2. That's cool. But we don't get Denard scaling completely because the devices are still the same and the wires are still the same, but they're physically smaller. So conceptually, we should be able to take advantage of that and get something like this scaling coming back, but we're going to have some kind of new architectures, new approaches to get there. All right, not particularly controversial, I don't think. The other piece that I think is not controversial is that there are plenty of tools out there. If you want to build a 3D system, you can do that. Things are there. We have solutions. You've heard from a couple of other vendors and so on. But what I want to talk about is what kind of innovation, what kind of tools, what kind of systems would be necessary to really, really take advantage of 3D. So what do I mean by that? Well, just a brief aside, I made a patio in our yard recently, and I had the shovel on the right there. And if you have a shovel like that, it's really good for digging round holes. But if you're digging a patio foundation, you discover that it's a square thing, and having a square shovel really, really helps your productivity. So I went to Ace Hardware, I got myself a square shovel, my productivity was immensely improved, yay. Having the right tools helps. You've also heard multi-scale a lot of times here, but again, if you're looking at this 6 orders of magnitude, what does that actually mean? It means that if you've got a handful of sand, that has the same physics technically as a pile of boulders, but they act differently in practice. So you need to think about that, and I wanted to give you an example. So let's suppose that you go across the bridge there and you go to Husky Stadium and you watch the Huskies play the Cougars. There are 22 people on the field. You can talk about the communication that those 22 people have with one another. Now let's add 3 orders of magnitude and say a third of the stadium goes and stands on the field. Now you've got 22,000 people on the field. What's that communication going to look like? It's going to look a little bit different. And now suppose you get everybody from San Francisco north and put them on or around the field. You've got 22 million. That is the 6 orders of magnitude. What does that communication look like? How can that kind of communication bandwidth density be used effectively? So that's what I want you to think about going forward here. All right, so where have we been? So we've started out, again, this is a repeat just even in this afternoon. You've seen stacks of individual dies. These things are designed 2.5D, maybe 3D. They're implemented as individual 2D die. Okay, that's before. Where are we at now? We're kind of in a co-designed era where you take something, you plan this thing in 3D, but you effectively implement it as a stack of 2D die. There's a coarse-grained level of partitioning. There's performance gains that you can get out of that, and there's some that are reported in the public literature, and there's others that you can, if you sign the right agreements, you can find out about. But there is performance gain to be had, but it's not the 41% that I talked about earlier. How are we going to get that? Well, if you think about it, now if we can take advantage of that massive amount of communication and actually co-design, co-optimize a structure, we're changing the way that these things are built from a stack of 2D things into a 3D object. So I was trying to think of an analogy for that would be useful. And a lot of what we've been talking about so far is really about sandwiches. Sandwiches are kind of a 3D looking food, but they're basically stacks of 2D things. You have some bread, you have some cheese, you have whatever, you stack it up, you get a sandwich. What we're talking about more is a casserole. It's a multi-layer actual 3D object. So if you designed really a 3D system as a 3D system, what could you do differently? That's potentially where this could be found. Well, how do you get there? Well, we have a usual crawl, walk, run thing. So what we've talked about so far is kind of in the crawl stage, where you take a die, you fold it, you optimize the metal, you do various things. That's the crawl stage. How do we get to the walk? Well, the key piece of the walk is effectively breaking this physical logical boundary. And so what the picture is meant to show is there's a signal that starts on some chip, it goes up to the next chip, it wanders around in logic space, and it goes down to the chip below that. That's hard. We heard, I was listening to Puya's talk, and I was thinking, okay, just what's the test implication of that? It would scare him, I'm pretty sure. But that's the kind of thing that we have to talk about. How do we build this thing? If it's going up and down, if we're really going to build this truly 3D structure, this is the first step that you need. You need the tools that let you do this natively. And how does that come into being? Well, there's a whole set of bits and pieces you need to do, but you need to do 3D synthesis, you need to do floor planning, you need to do architecture exploration, and so on. But once you've done that, then you can get to this run stage where you have really true native 3D design system flow. That's the goal that we should all be shooting for. That's where you can get your 41% more improvement. Thank you.